Let us start the stream, guys. I hope so that I am audible. Hello, hello, hello. And also I am visible at the same time. And the stream is live. Looks like the stream is live, but is my video feed is available? I don't think so. Yeah. It is there. Okay, guys. Let us start the session, guys. Welcome back to Coders Arcade. This is Ashang David, and in today's live session, I am going to talk about. This is going to be 23rd live session, and this is all about. I'm going to talk about today Splay Tree. Splay Tree. It's a very important concept, guys, and it is a very it's a concept of it is a concept which is not taught in every college, but this is a question which is asked in placement. So today we will discuss about that. So welcome back, guys. Let us start. And my light is not on, so my light and my camera, I'll just apologies, guys. Let me just set up my camera. Yeah. All right. So here we are. Let us start today's class, guys. Okay. Without any further ado, before I start with this class, guys, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Also, don't forget to share this stream as much as possible so that those people who are really interested in learning live sessions and DSA all for free, they can also learn from it. If you are looking for the course to end very soon, let me tell you that this is a YouTube live session, and in this YouTube live session, according to however the classes are going on, it will finish on time. I'm trying my best to finish this course by the end of this month. But if you think that it is going to be late for you, and if you want the course, if you like our training, and if you want a crash course, we are providing crash courses also. So you can contact us onto our company's channel info. The links and everything is given in the description below. Don't forget to connect with us into our Telegram channel also, and soon we are going to build up our WhatsApp community as well. So stay connected, guys, and I will be posting all the things, everything related to our placements, internships or whatever very soon. Also, at the end of this live session, I have a surprise for you that I'll be telling you at the end. I have something. It's not kind of a surprise, but I can say it is something which is important for your placements, that I'll be telling you at the end of this session. So stay tuned till the end of this session, guys, and let us start this video, guys, without any further ado. This is Ashang David, and let's begin our class. So guys, in the last class, where did we start? In the last class, we had just finished our binary search tree concept, and we were also about to start the splay tree concept. Okay. So we are about to start our splay tree concept. So let us start. Mahesh, hello sir. Odisha, hello sir. Live, yes. Hi guys, hello everyone. This is Ashang David. Let us continue. Okay, so in the last live session, we were talking about what? We were talking about binary search tree, BST. We were talking about BST, where we have finished up the whole concept of BST. Absolutely fine. What all things we have done? We have done insert, we have done deletion, and then we have done searching, we have done traversal. In traversal we have done DFS, and we have done BFS. In DFS we have done in, pre, and post. So all of these things we have already finished. So if you haven't watched our previous live sessions, I would highly recommend you to go ahead and watch those live sessions before and then come to this video, because this video is going to be the part of the previous live sessions. So today I'll be a little bit fast, guys, and without wasting our time, because the time is very less and we need to finish up this course also at the same time. So I'll be a little bit quick, I'll be a little bit fast, and today I'll just explain you the concept of splay tree. It is easy, it is comparatively it is very easy. The trick here is to understand the logic, and once you understood the logic, it becomes very easy, guys. Okay, guys, so let us start. So what exactly is a splay tree? Let us continue with our today's concept of splay tree. Splay tree. We are talking about splay tree. So guys, splay tree. What is this splay tree? So you might have seen some softwares or some applications. You might have seen some softwares or some applications where whenever you try to access anything, the next time when you open that up, the recently accessed elements are brought up to the top. Now for example, right here you see, this is what application? This is Microsoft Whiteboard application, correct? Now if I go to home, I know it is going to be a little bit on the brighter side. Let me just make it correct a little bit. Now guys, I wanted to show this to you, so that is why. Wait a minute, guys. Now you see here. I hope so this is much more visible. Okay. Now this is much more visible. Now you see, I have created this whiteboard recently. Okay. So when I created this whiteboard recently, this whiteboard has came up to the top. Now if I zoom in here, you see, check this out, guys. If I zoom in here, you see that this element is what? The first one is untitled, correct? The second one is Python B103 day 4 batch. This is two whiteboards here I have created. I have created two whiteboards, okay? And recently I was working on this untitled right here at 7:19 p.m. As you can see, this is just the time right now. So I am not giving the whiteboard its name, but this is what we were using right now, where I was explaining you the concept of a splay tree. Now, just before that, at 6:24 p.m. I was working on this, but I accessed this. So this came up first. Let us open up this. I opened up the previous one, and when I opened up the previous one, you see what happened? This is the previous file, and now I am going back. You see what happens? This was the previous one, this came above. This is the recently viewed whiteboard. Are you getting my point, guys? I hope so that I am visible and it is understood. When I accessed this Python B103.7.24 day 4 batch whiteboard, just now my class got over before this session, so I was teaching there here, but when I used this file came up on top. Now untitled has moved it below, correct? Now if I click onto untitled and if I open up untitled, you see this is the file which we were using, correct, right now. Okay. Now I go back home and you see that untitled will come up. Did you observe something here? Did you observe something? We observed here that whenever we are trying to access any file, the recently accessed file is coming up on top, and just before recent accessed file is kept just below it. I hope so that you are getting my point, what I am trying to explain you here. Understood? Now I will set up the camera back so that it is visible to all of you. What I wanted to explain is now I have already explained, and I will open up our whiteboard, continue. I hope so that you have understood what I am trying to say here. I will increase the ISO so that okay. I hope so that this is very much clear. No, it is too much. Apologies guys, I am still learning about this, but anyways, yeah, perfect. This is fine. This is fine. Okay, yeah, I came back. So you understood this, guys, that here we observed one thing, that whenever we try to access the latest accessed file, whenever we try to access the latest accessed file, it comes up on the top. Okay. This logic is actually used in Splay Trees concept. This logic is actually used in Splay Tree concept. You see, I was about to explain you about a Splay Tree. Let us understand that properly. Okay. So I was talking about Splay Tree. Splay Tree. Okay guys, and I hope so that it is visible. It is not out of the screen as well. It is visible, correct? Okay. So here, what exactly is the concept of Splay Tree? Now Splay Tree is a type of a tree. I'll write here, Splay Tree is a type of a tree where the recently accessed node is kept on to the root node, on the root node. Just now I have explained you that example of that Microsoft whiteboard. You saw that when I accessed the untitled whiteboard, the untitled whiteboard came up first, and when I accessed the previous Python batch whiteboard, the Python batch whiteboard came just above it. Whenever a recently accessed data is accessed, that recently accessed data comes up onto the top, allowing for your easier access to the previous accessed data which you have recently accessed. This way you will save a lot of time. You don't have to navigate all again to hundreds of pages or hundreds of lines and then access that particular thing, but that automatically comes up on the top. So this is how the recently viewed pages work, or this is how recently added or recently accessed data is accessed. How does it happen? The concept of Splay Tree allows us to do this. Well, I hope so. I am very much clear to all of you about this, about the concept of Splay Tree. Splay Tree is the tree on which when I access the node, that node comes onto the top. This is what you call as a splay action. Okay. Let us continue. Let us say you have this tree. Now this is a binary search tree. You already know about binary search tree by now. Okay. Now let us talk about it. Let's say for example I have 100 here, 50 here, 150 here, and this is gonna be 30, this is gonna be 70, this is gonna be 120, this is gonna be 170. So this is the binary search tree that we are having. Now in this binary search tree, I am saying that I want to access this 150, and when I access this 150, this 150 will go up now because it has become the recently accessed, and this will go on to the new root. This will become the new root, and the root will come one down onto the left hand side of the node, because of course it needs to maintain the BST property also at the same time. I hope so that this is very much clear to all of you. Clear? So in this case, your new binary search tree would look like this, where 150 is on the top as a new node, which is actually recently accessed. On the left hand side we have 100, and on the left hand side of the 100 we have 50. Okay, and this is your here we will write 120. So the whole thing will get actually adjusted into this case, and you see that this is 30, this is gonna be 70 in this case, and like this it will go on 170. Understand the point? So like this the whole tree got changed. So now this has become the recently accessed node. So the next time if you want to access the node, this node could be accessed on the top right there. I hope so that this is very much clear to all of you, and this is how the concept works. Alright guys, I hope so that this is very much clear. Now if we talk about the code for this, this is the code which I have prepared to show you, to explain you. And here in this code is very similar to what we have done in BST, in binary search trees. In binary search trees we have created the helper functions and the public functions. So that's the same concept I have applied here. I have tried to maintain the same type of code and same style of coding, so that those people who are coming from our previous sessions are also able to understand this new session of Splay Tree as well. I hope so the logic of a Splay Tree is very much clear. Now let us understand about the code. Okay guys, and 1 minute before I start explaining the code, let me just press the button, otherwise the camera will shut down. Okay, yeah, we are back here. Now let us start our code part. So you guys see that I am starting with hash include IOStream, and I am writing queue. I am including queues, STL queues. Why? Because later on I will be doing BFS traversal, and we all know that BFS requires queue to be used for the traversal. Understood? I hope this is very much clear to all of you. Apart from it, those people who don't know about this of BFS on DFS, just look at our previous video. This is session number 23. Just to go to session number 22, where I have explained you the both BFS and DFS traversal of binary search tree. Okay guys, now let us start. So I have written IOStream and the hash include queue. This is for our BFS traversal using namespace std, and I have said here the class node, and you observe here that the node class is exactly the same, because it is ultimately a binary search tree only. Understood? So public int key, node star left, node star right, absolutely the same. Then we have written the constructor node int k, key equals to k, and then null pointer, right, null pointer. Everything is the same, there is no changes into it. Okay. Now class Splay Tree, we have created another class called Splay Tree, where again we have divided the whole tree, just like how we have divided the whole tree for BST. Now the same thing we have done it for Splay Tree also. We have taken two spaces, that is one private space of this class Splay Tree and the public section separately for the class Splay Tree, where in the private section we are defining the root, we are declaring the root, and writing all the helper functions. So this is to utility, this is utility function for rotation, and this is the splay function which is actually doing the splaying part, and this is gonna be your public section of the class. Public section of the class. No, insert, this is insert recursively function, void function, and BFS traversal. This is public section of the class where we are writing the constructor for the splay tree, and root is equals to null. Guys, if you think that the code is way too longer, if you think like that, then you will not be able to do it. Trust me, trust the process, and just look at the code and try to understand it. Okay guys, I hope so that this is very much clear. Okay, if you look at the code, that code is too big, then you will never be able to succeed to learn this. Okay, don't look at that like that. Now we, in the public section, we have the constructor through which we are creating root as null pointer. We are initializing the root as null, and here I have the insert function void insert int key, where I am updating the root and recursively inserting the same logic of BST. Okay, then we have search function just like BST. To search, we have in order traversal, we have in order BFS, and this is our main function. The main reason I have not written the delete function is, this is the splay tree, and rather than focus on to deleting will be same as BST. Either there will be two cases created, either if the left child is present, or the right child is present, or the 0 child is present, or 1 child is present, or 2 child is present. The same logic will work here also. So I have not mentioned that delete function in the code, but the same code for BST will also work absolutely fine in this case also. So you can apply that right here. Okay guys, so here in the main function we are creating the splay tree, and this starting inserting, so 50 30s like this we are inserting, and while it is getting inserted, I am just doing in order traversal and BFS traversal. We will focus on to more BFS traversal, which will give you an idea of how this play is actually happening. And let's focus on to our private section of the class, which is important. We are going to, I am going to skip this BFS helper part, because this I have explained hundreds of times in the class, and I hope so that if you want to understand this BFS helper class, you can go ahead and watch our previous sessions. If you have not watched the previous sessions properly, you will not understand this. Guys, don't take me wrong, because time is very less, I need to rush. So I am leaving this for the explanation. I have already explained this 2 times, one in binary trees, another in binary search trees. Okay guys, so if you want to understand, please do understand in our previous live sessions. Apart from that, this is our in order DFS function, which is also the same. You can watch it in the previous session. So traversal function is done. Search is also, now search and insert function, we will quickly see that, and then we will move on to the main 3 functions, 2 utility functions and 1 splay function. Understand that, and we will quickly move on. This is insert recursively function. Now it works very similar to the BST insert recursively function, where we were able to do the insertion very quickly. So you see that in insert recursively we are taking the root and the key, checking if the root is equals to a null. In that case, if the root is null, then insert the root itself, the value itself at the root. So assign the new node value and then put it, just like how we have done it in the previous sessions. I hope so that this is very much clear. Okay guys, then we have updated the root by calling the splay function. Guys, remember this, as soon as you do the insert function, you need to do a splay. Splay means the recently accessed element will come up on the top. This will show you the recently inserted elements, because the recently inserted is the recently accessed element also at the same time. So as soon as you insert the first element, you will do a splay operation. We will talk about this splay later on. It has a whole different function in it. Understood? Now once it is splayed out, checking if the root key is equals to the key, then we will return the root if we want to search, or we can create a new node, and if the key is lesser than the root key, then it will go on to the right hand side of the root, and from the left hand side we will go to left and left side. This is very similar to what we have done it in the BST insert function. I will give you the link of the whole code in the description in the comment section below. I will pin up the comment. I will pin up the whole program in the comment section below, and later on if you have any doubts I can explain you that after the session ends. Okay. The same thing which we are doing here with the else part. If the root value is going towards the left, in that case you will do newly created nodes left will be on the root, and no newly created right will be the root's right itself. Okay guys, and at the root's right we are making it as null. It is very similar to heap data structure. The next concept that we are going to do is the heap data structure, where you will understand this concept very properly. So as of now, when I will give you the code, try the code, try to understand it for yourself, practice it once, and even if you are not able to understand, then ask me the doubt. I will be there, I am gonna be there till you have not understood the concept. Okay guys, so this is your insert function. The search recursively function is just because this Splay function is anyways doing searching. So in the search recursively function we are gonna call the Splay function. Ultimately this is our Splay function which we are here for. This is the main function, Splay function, for which we are actually here in today's class. So we have written node star Splay. The Splay is to bring the key to the root, whichever value is being accessed recently. This Splay function will bring that value into the root or the top of the tree. Got my point? So let us understand how it happens. So you see, if the root is equals to null, this is one case, or if the root key value is equals to the key value, in that case you will just directly return the root that is recently accessed anyways. Understood? What happens now? There are two possibilities guys. If you understand with the help of an example, say for example this is your tree. This is your tree. This is your tree. Okay. Now, when my camera went off, one second guys, I'll be back. Yeah, I'm back. Okay. So there are two things guys. One thing, if divide, first of all divide this whole tree from the middle. Divide the whole tree from middle. Okay. Divide the whole tree from the middle. There are two possibilities guys. One possibility is the node which you are searching for is on the left hand side, or the node which you are looking for is on the right hand side. So you will do a Splay on the left hand side, or you will do the Splay on the right hand side. These are the only two possibilities that can be occurred in the program, correct? Because it is a binary tree, either the value will be on the left hand side or the value will be on the right hand side. Absolutely correct guys. You understand the point? So first, looking for if the key lies in the left subtree. So key will be smaller than the root key. If the key is smaller than the root key, then this is the logic. If the key is larger than the root key, then it will go to the right hand side and will do the same exact logic. That is what it makes very much complicated to understand. But wherever you are writing left, the same thing you have to write it with right, and it will become the code for both the cases. So actually we need to solve and understand about the left hand side or the right hand side depending upon your comfortability first. So let us take an example of left hand side first. So right hand side you can just replace left with right and copy and paste the same exact code for in the else part. So there are two conditions here. First condition, if on the left hand side, and then this condition is getting overwrite over here for the else part if the. So you understood there are two outer if else. Inside this outer if there is inner if, checking if the roots left is null. If the roots left is null, that means the root is, we will return that root in that case. See guys, we are not bothering about this. Imagine if the root left is null, that means this is null, then of course this is gonna be returned. We are not caring about that right now, the half right. We are not caring about that, because the same thing is gonna get happened here what I am doing this side. This is like a mirror. We have cut down the whole tree into a symmetry. So if this is not there, then I will return this. The same thing I would do here also. If this is not there, then I would have returned this. Understood? Because it is the same symmetry, I would have done the same thing, correct? So in this case also I am doing the same thing. If the root of left is equals to null, then return the root, done. But this is not the case in the R case. Now you see, it might be possible. There are two if else condition statements here. Okay, what are those? Guys, imagine that none of them are null. That means this is true that they both exist. Okay, that condition fails and this is proved that they both exist. Now in that case what you will do? It might be possible that the element which you are searching is on the left hand side's left, correct? Or it can be on the left hand side's right also. Understood my point? This part. Is this clear or not what I am trying to say? Listen to this again. I am saying it is possible that maybe this is your key or the target value, or maybe this is the key. So there are two conditions. If the key is at left, if the key is at left, this one, or else if the key is on the left and again right, on the left and again right, either this or maybe this. Hope so that this, are you guys able to understand this concept or not? We are not talking, forget about this right hand side right now, only focus on to the left hand side. Saying that this is gonna be left or left right. Okay guys, in that scenario, see, if the key is root, key is lesser than the root's left key, means it is on the left. It is on the left. Key is lesser than the root's left. The key is lesser than the root's left. The key is lesser than the, if it is lesser than this left, means it is this one. Understand the point? Or else, if key is greater than the root's left key, if the key is lesser than the root's left key, greater than the root's left key, greater than the root, that means greater than from this, that means we are talking about this. So there are two possibilities, either left or left right. This is left, so this is left, this is left, this is left, so this is right. I know it is a little bit confusing at first, but you see that it is comparatively easy. The way that I am explaining you, I am trying to be as smooth and as slow and as simple as possible. Okay guys, so I hope so that this is very much clear. This is root, I know this is root, so roots left or roots left right, but in code you need to write something. So what you will write? If the key is lesser than the roots left, key is lesser than the roots left, then it is on the left. So if it is on the left, so go to roots left and call display there. Again, call display there. If this is the case, then call display right here. And this will be the key, this wants to be accessed, so this will be accessed and this will be brought up right here. Understood my point? I hope so that this is very much clear to all of you. Okay? Understood? Or else, if the key is greater than the roots left, that means it is on the left right, then what do? Go to this and call display. Splay will bring this to the root. I hope so that this is very much clear. So if that is the case, then go to roots left right and then call the splay function with this guy. Hope so what I am explaining is very much clear to all of you. This is the zigzag value. Keep on doing this until the root key is matched with the key. It will keep on going. Left, right, zigzag, like that. I hope so that this is very much clear. This is zig-zag, and this is also zig-zag. That is why we are calling it as zigzag left, zigzag left, right. I hope so that it is very much clear. It is comparatively easy, guys. You are thinking that it is tough to understand because this is a very new concept, but it is not that difficult concept. You guys, come on guys, you guys have survived binary search trees. Binary search tree was one of the worsts. This is like binary search tree, and it is not as worst as binary search tree. So this is comparatively easy from binary search tree. Well, I hope so that this is very much clear. So zigzag thing you need to do and call the same function. Done. The left side is done. Why you recursively called it? The splay function? Because it might be possible that it may have more children below. So keep on recursively calling it until you find it, recursively call it, keep on swapping until it reaches the root node and it is splayed. Hi Chandan Kumar Sharma, hi, hello, welcome, you are late, I am about to finish the class and my camera also got switched off, so I will switch it on. I hope so that this is absolutely clear to all of you. Same concept, copy paste, write it in the else if part, that becomes what? That becomes the right hand side of the tree. It might be possible that this is null. If this is not null, then it might be possible then key is present onto the right left or right. In that case, go to this and call the splay function. So try to make this bring here or maybe this here. Keep on doing this recursively until your tree is splayed. Chandan Kumar Sharma, sorry sir, it's okay Chandan Kumar Sharma, the recordings are there, you can watch it, but today it was a very important concept. Okay, anyways, and I have forgotten to send a lot of links in many social media platforms also, so I will be putting up the link for the recorded session. Today I was in a little bit of hurry, so I was not able to broadcast about this live session that I was about to happen. It just came with a lot speed and it just bam, it came and I just came live. It was like that. So even I did not get time today for broadcasting about this stream. Just now I have scheduled it and just now I have went live in 1 hour, like 1 hour back. So the recording will be stored and the notes will be provided right in the description below, guys. The code is, I hope so that it is understood very well. You see that one thing that we were doing here, we have written the utility functions. Okay. So what we have done is we have written the right rotate utility function and left rotate utility function. For rotating any of these elements either from here to maybe here, first bring this guy here. So this is right rotate in the zigzag and this is also left rotate in zigzag. So to do that, we have already written our utility functions that you can use to do it. I will provide the link of the whole code in the description below, and I hope so that today's concept is really very much clear. Today, without wasting any time, we have done a lot of things. Yes? Yes, Mahesh, clear. So ultimately, what is the moral of the story for today's class? Moral of the story is, Splay tree is a type of a tree which adjusts all the node to the recently accessed on the root. Basically, what happens here is, whichever node you access in the tree, that node becomes the root node and that becomes the newly created node. Why this happens? Because the extraction from the root becomes easy. I hope so that this is very much clear. This is what you call as a splay tree. Splay tree is just a tree which brings all the recently accessed element on the top of the root. And that is all about today's live session, guys. Thank you so much for watching. Now, time for the thing which I told you in the beginning that I will be telling you. For those people who are waiting till now, listen to this very carefully. I am about to start mock interview sessions. So by tomorrow or day after tomorrow, I will be putting up a Google form link in our Telegram channel. Telegram's channel link is been already given in the description below. Listen to this, guys, carefully. For those people who are not here and later on watching this recording, I will be very soon, not very soon, by tomorrow or day after tomorrow, I will be putting up a Google Forms link into our Telegram channel. That Google Forms link will be a small entrance test for mock interviews into Coders Arcade. And this is all for free. We are not charging anything for it. So for our subscribers who are watching this live stream and learning on the daily basis, I wanted to do something extra. So I have planned that I will be conducting mock interviews also for technical sessions for different companies. If you want to sit live, we will be coming live together, guys. Like how I am live right now, I am going to be live with you taking your interview on YouTube. Terms and conditions applied. If you are not comfortable coming live on YouTube with me, no problems. With your consent, we will be taking up either the mock interviews either privately, or we will conduct, those people who want to come live with us will conduct mock interviews live onto our YouTube in a particular slot of time, maybe on Saturdays, not every day, but in a week, once in a week, or maybe twice in a month. We will be doing this on Saturdays, because Saturdays I think so that people will be available on Saturdays for conducting the mock interviews. I will be conducting mock interviews, guys. So if you want to take part into mock interviews, I will be putting up the link to the Google form for entrance test, a small entrance test. Imagine this entrance test is going to be your technical written round, and based off of that, the questions will be asked to you in your mock interview exam. We will be giving you real-time company's exposure of how it feels to be like sitting in front of an interviewer, where I will be your interviewer live on YouTube, or maybe privately in just a private session, and I will be conducting mock interviews. Hello Ronnie Plays, hi, I just told the information for today's class. I will be conducting mock interviews online. So if you are interested to come live with me on my channel Code is Arcade, conducting mock interviews. Definitely you are welcomed. I'll put up the link of the Google form in the Telegram by tomorrow or day after tomorrow. So don't forget to fill that up, submit that up. That is going to be the entrance test for our mock interview sessions. Those people who are interested to join our mock interview sessions, please do fill up those forms and submit it. It will be a Google form link I'll be giving you guys. Just submit it up. Soon will be conducting the mock interviews, live sessions. It's up to you. If you guys want to come live with us, I can conduct live interview sessions, and or maybe I can do it privately. However it is, I'll be doing that. So if you are interested in that, I'll be giving the link very soon in the Telegram channel below, guys. So do not forget to follow us on Telegram. Do not forget us also, and do not forget to follow us on Instagram and other social media platforms, guys. It will be of great help for you guys. Support like this motivates me to bring you more content like this, explaining you each and everything about DSA, all for free. So guys, if you are interested, please do let me know in the Telegram channel. I'll be posting the link for this video recording sessions, and the notes for today's class I will be providing in the Telegram. So guys, share the Telegram channel link to many people, and so that they can also join us. And you also, if you are new to this channel, please do hit like and share and subscribe to our channel, and don't forget to press the bell icon also, and also subscribe to our Telegram. Very soon I'm opening up WhatsApp community also, WhatsApp channel also. So if you are interested in that, I'll be posting updates onto WhatsApp channel as well. So make sure to follow us on every other social media as possible. I hope so that today's class is very clear. Have understood each and everything today, guys. Well, I can sure sir, I will be there. Yes, Ronnie, please. Absolutely fine. I'll be there too. Good. If you have any other doubts, please do ask me before leaving. I can have 5 to 10 minutes of doubts clearing session, and then I'll end up this live stream. If nobody is asking any doubts, I'll end up the stream right away, and I hope so today's concept is very much clear. I'll give the link of this today's session into the Telegram channel. Link for the notes will be given into the description below. With the code, I will pin the code into the comment section as the first pinned code. So if you have any doubts, please do ask me in the comment section below, and I'll be there. It will be my pleasure to solve your doubts, guys. Thank you so much for watching, guys. And if you have any doubts, yes, I'm there to help you. No doubts, I'll be closing this stream, guys. So no doubts, I hope so. All is clear, sir. Okay. Alright guys. So thank you so much for watching, guys. And my camera went off. Okay. Yeah. So guys, again, thank you so much for watching, guys. I hope so. I have to watch the whole session again, sir. I was late to the class. Yes, please do watch it. And if you have any doubts, please do let me know in the comment section. By tomorrow, I'll be clearing all your doubts. It's already night and the office is getting closed, so I'll be clearing all your doubts. By tomorrow morning, I'll clear all your doubts. And if you have any other problems, do let me know in the comment section below, and I'll see you there. Tomorrow's class will be at the same time, 7 p.m. Indian Standard Time. And that's all, guys. Thank you so much, guys, for staying till the end of the video. I'll see you guys tomorrow evening again, right? So I'll be then switching off the stream, guys. Thank you so much. Thank you, guys. Thank you, guys. Thank you, Ronnie Place. Thank you, Mahesh. Thank you, Chandan Kumar. Thank you, Deepak Soni, Jamil Rahman. Thank you so much, guys. Thank you so much for watching my stream. I'll see you again tomorrow. Till then, take care and happy learning. Stay safe, and I'll see you guys again. This is Ashank David signing off. And